In this video, we will go through finding the derivative, so finding the first derivative and finding the second derivative. On your screen now, you can see there is 5 rules going through what to do when you're given a certain term. All those rules are following the formula that's also on your screen in the green box below. So let's bring our attention straight to the formula down here. Okay, so it says if y equals x to the power of n, then dy dx equals n multiplied by x to the power of n minus 1. So as you can see, this formula is in your formula book, so you do not need to learn it off by heart. Also to note, dy dx is just notation for derivative. It will always have d at the start, however the y and x can change to any letter of the alphabet depending on which variable is in your function. However, majority of the time it is y and x. So for example, if we had 2x to the power of 4 and we were asked to differentiate it, so we were asked to find dy dx of this term, then we would apply the formula right next to it. So in the formula we can see that n is the power, so I must bring n down in front of my term. So my power here is 4, so I bring 4 down in front as a multiplier, and it is multiplied by 2x, and then we can also see that in the formula n minus 1, so again n is 4 minus 1. So I've taken my term, I've brought the power down in front as a multiplier, and I've minused 1 from my power, as the formula tells us to do at nx to the power of n minus 1. So now tidying that up, I have 4 times 2x to the power of 3. And then when multiplying algebra, you can multiply variables and variables and constants and constants. So here I'm going to multiply the 4 times 2 is 8x to be cubed. So 2x to the power of 4 differentiated gives me 8x to the power of 3. So that is my answer there, that is the derivative. Now as you practice and get quicker at these, you don't necessarily need to write out bit by bit the formula. If you can bring down the power, multiply it by what's in front of your variable and minus 1 from the power. If you can get into that rhythm of going, you can simply go from 2x to the power of 4 straight down to 8x to the power of 3. Okay, so let's practice a little bit more. So we have some questions here now. It says differentiate the following with respect to x. So we're given the function y equals 4x squared plus 2x plus 6. So we're asked to differentiate this, so we must differentiate each term individually. So the first term I'm going to differentiate is 4x to be squared. So again, since it's y and x's in the function, I'm going to use the notation dy dx equals. So again, I take the power and I multiply it by what's in front of my x. So my power is 2, so I'm going to say 2 times 4 is 8x, and minus 1 from that power, 2 minus 1 is 1. Now in math, particularly with algebra and powers, we're not in the habit of writing the number 1, so that would just be 8x. Next we have 2x to the power of 1, so 1 times 2 is 2, and then minus 1 from the powers, that leaves me 1 minus 1, and Also to note, when we're differentiating, we do not differentiate constants. They just go to 0, so any normal number, you can just score it out, we don't need it. So tidying this up now, so we've got 8x plus, so that's going to give me 2x to the power of 0. And from our indices, we have learnt that anything to the power of 0 is just 1. So I can replace that x to the power of 0 with 1, and 2 times 1 is just 2. So any time you have a term to the power of 1, so here we've got 2x to the power of 1, what really happens is we can just drop off the variable, leaving us with only the constant. So 4x squared plus 2x plus 6 differentiates down to 8x plus 2. Now, let's have a look at another one. So question part 2 there, we've got y equals 3x squared plus 10x plus 2. So again, it's x and y's are the variables used, so I can see dy dx equals, so 3x squared, so you take the power, multiply it by what's in front of the x. So 2 times 3 is 6, minus 1 from the power, 2 minus 1 is 1. And again, we don't write the power of 1, where it is assumed that it's there. Plus, so 10x, so 1 times 10 is 10. Then, if we minus 1 from the power, that leaves us with x to the power of 1 minus 1. And again, any constants, so any number without any letters beside them, we don't differentiate, we can just forget about them. They go to 0, so they don't add any value. So again, tidying this up now, we've got 6x plus 10x to the power of 0, which gives me 6x plus 10, as again, anything to the power of 0 turns to 1. That's one of the laws of our indices. Right, another example. So, a good idea here now is, if you would like to pause the video and try parts 3 and parts 4 and parts 5 yourself, pause the video now and try them, and then correct your work, play the video again, and you can watch me go through them here now. So, part 3, we'll squeeze them down here. So we've got y equals x squared plus 9x plus 12. Again, we're asked to find the derivative, so it's going to be dy dx equals, so x squared, so 2 times 1 is 2x, minus 1 from the power leaves me with 1, plus 9x, 1 times 9 is 9, minus 1 from the power leaves me with 0, and we can't differentiate constants, they just turn to 0, so we can just drop them there. So then tidying this up, I've got 2x plus 9, as we must remember that, I'm going to write it up here, x to the power 0 equals 1. Okay, so that's important to note. So then again, moving on to part 4, so correct these as we go along. So part 4, we have 3x to be cubed plus 4x minus 3x, 4x squared minus 3x plus 8. So 3 times, so again, power multiplied by what's in front of the x minus 1 from the power. That's the 2 steps we're doing here to each term. Power multiplied by what's in front of your x minus 1 from the power. So 3 times 3 is 9x minus 1 from the power. 3 minus 1 is 2. Next term, 2 times 4 is 8, minus 1 from the power is 1. Next term, so we have minus 3x to the power of 1, so 1 times minus 3 is minus 3, minus 1 from the power leaves me with x to the power 0. And differentiating a constant, normal number, we don't do that, so we can just cross that off. Then tidying this up, we have 9x squared plus 8x minus 3, as remember x to the power of 0 equals 1. So if you replace the x to the power 0 with 1, you'll be multiplying by 1, which would just give you 9x plus 8x minus 3. And then last one. So again, correct them as we're going along. This one's a bit shorter. We have 3x squared plus 4. So taking one term at a time, power multiplied by what's in front of your x, then minus 1 from the power. So 2 times 3 is 6x, minus 1 from the power is 1, 2 minus 1 is 1. And then differentiating our 4, we just cross that off as it's a constant, which leaves me with dy dx, my derivative in this case being simply 6x. I hope you found that helpful. So that is our first derivative. You take one term at a time, and we must remember anywhere we see x to the power 0, it turns to 1. So it's the same thing each time. We're following the formula from the first page, is where you multiply in front of your x by your power and then minus 1 from that power. Now, again, to test yourself, please pause the video now and try the following two questions at the top of your screen. Question 9, it says find dy dx when. Okay, so hopefully you got on okay with those. So let's go through the answers here. So the first question is y equals x cubed plus x squared minus x plus 1. So again, same formula. Power multiplied by the front minus 1 from the power. So I'm going to say 3 times 1 gives me 3x minus 1 from the power leaves me with 2. Next term, 2 times 1 is 2 minus 1 from the power leaves me with the power of 1. Minus x, so that's to the power of 1 since it's not written. So we say 1 times minus 1 is minus 1. Minus 1 from the power leaves me with x to the power of 0. And then we have differentiating a constant, normal number we don't do, so we can just cross it off. And then tidying this up, we have 3x squared plus 2x minus 1. As remember, anything to the power 0, so x to the power 0 is just 1. And when you multiply by 1, you're just left with what you had. So that was part 1. Part 2, we have y equals 3x cubed plus 2x to be squared minus x plus 1. So again, following the rule, take the power, multiply by what's in front, and then minus 1 from your power. So 3 times 3 is 9. X minus 1 from the power, 3 take away 1 is 2. Move on to the next term, start again. 2 times 2 is 4. Minus 1 from the power leaves me with just 1. Minus x, so that's the power of 1. So 1 times minus 1 is minus 1. X to the power 0, that's like minus 1 from the power. Differentiate the constant, we don't do, we just cross it off. Then tidying this up, I get 9x squared plus 4x minus 1 is x to the power of 0 turns to 1. Okay, so that law of, and this is very important here, you can see it creeps up a lot. So I hope you got on okay with those. So that's first derivative done. Let's move on to our second derivative. So our second derivative is kind of what it is called. It's derivative the second time around. So in order to find the second derivative, we must first find the first derivative and then take that answer and follow the procedure again. So we differentiate twice in a row to get our second derivative. So you can see we have notation here up the top. So it's d squared y dx squared. Or we can have f double prime of x. So either notation can be used. So questions here, so let's see a little example. So part 1, so dy dx. So I'm given the function 12x to be squared minus 2x minus 6. So dy dx. So again, same formula, same steps. Take the power multiplied by what's in front, minus 1 from the power. So here I've got 2 times 12 is 24, minus 1 from the power, so 2 times 1 is 1, minus 2x to the power of 1, so we say 1 times minus 2 is minus 2, and 1 from the power, 1 minus 1 is going to leave me with 0. And again, same as usual, we don't differentiate constants, we can cross that off. Now let's tidy up our next line. So our first derivative is 24x minus 2x to the power of 0, which just turns to 1. So minus 2 times 1 just leaves me with minus 2. So my first derivative is 24x minus 2. Therefore, if I was asked for the second derivative, I then take my answer of my first derivative and I differentiate that. So 24x is to the power of 1, so 1 times 24 is 24, minus 1 from the power is 1 minus 1, and again, as usual, we do not differentiate constants, so we can cross that off. Tidying this up, we get 24x to the power of 0, which we hopefully now will know turns to 1, so we have 24 to the power of 1, which is simply 24. So 24 is my second derivative. That's my answer. So to get your second derivative, you must find your first derivative, then take your answer, find your second derivative, and that will leave you then with 24. So that was the first question right here. Please complete the rest of the questions on your screen. So you can see there's 4 more in those section of questioning. So find the first derivative, then find the second derivative. And when you have those done, there's more questions here now. So there's 2, and they're asked to find d squared s dt squared. So because the variables in those functions is s and t, you can see that s and t is used in notation for derivative, but it's the exact same steps. If you have any questions for me regarding calculus differentiation, please don't hesitate to ask. Either email me, I can check any work that you do, I'll correct it for you happily. So just ask me either in class or email me. Thank you very much.